Today we're going to look at solving log equations that are a little different than what we saw in the last video. So in the last lesson we had, like for instance here, we had log base 11 on this side and also log base 11 on the other side of the equation. As you'll notice here, we only have log on one side of the equation. So I can't start by canceling out logs on both sides because I don't have logs on both sides. The process we're going to use today is called exponentiation, which sounds a lot scarier than it is. All that means is that to cancel out a log, we use a base, like an exponent base, to cancel that out. And so what I mean here is if I have log base b of x, what I can do to cancel out log base b is use a big B base like this. These two things cancel each other out. Anything I do to one side of the equation, though, I have to do to the other, which I'll show you here in just a second. So using number one as an example, I have log base 11. So to get rid of that log base 11, I need to use an 11 base. But anything I do to one side, I have to do to the other. Like I said, log base 11 and 11 are opposites. They cancel each other out, and we get just x. The other side becomes 11 squared, which you can do by hand or in a calculator. Either way, you get 121. So key thing here is don't do 11 times 2, 2 times 11. You're doing 11 to this power. X is now completely by itself and equal to a number, so I am finished. We're going to do the same process for the rest of these. Next up, here I have log base 8 of 3m. So I'm going to use an 8 base because I have log base 8 here. And we use an 8 base on the other side. That weird sound was my dog trying to barge in. So he's fine. 8 and log base 8 are opposites, so they cancel. So I get just 3m here. 8 to the 0 power. Anything to the 0 power other than 0 is 1. So I get 1 on this side. I'm not completely done yet though, because I want m completely by itself. To get m by itself, I need to divide both sides by 3. And so I get m equals 1/3. You could also write this a decimal point 3 repeating if you'd rather. Carrying on. Next one, I have log base 7. Undoing log base 7, I use a 7 base on both sides. 7 and log base 7 cancel each other out. We get just n. On the other side, I need to do 7 to the negative 2. 7 to the positive 2 is 49, so 7 to the negative 2 is 1/49. So I get a fraction there, that's not a problem. N is completely by itself, so I'm all finished. N is equal to that fraction, 1/49. Next up, once again, it's log base 7. So I need to use a 7 base on both sides. 7 and log 7 cancel each other out. So I'm left with the argument stuff equals 7 to the 1. 7 to the 1 is just 7. From here, I solve for n. So just like any other equation, I'm going to add 6. And then last but not least, divide. So I end up with n equals 13/7. Fraction answer is okay, not a big deal. Now the last two had something missing. In order to figure out what base we've been using, we just look at the base of the log. However, we don't see a base of a log. Whenever you don't see a base for a log, so just log x, that's the same as log base 10 of x. This is the only thing I can think of in math when the number is hidden. It's not a 0 or a 1 or a 2. In this case, it's a 10. So if you don't see a base, it's like having a base 10 there. You can write it in if it helps you. Since that's a base 10, we're going to use a 10 base to cancel out that log. So when I do that, 10 and log or 10 and log base 10 cancel each other out. Remember to do it on the other side of the equation as well. I forgot to write that. Silly me. 10 to the 4th is 10,000. And so then the very last thing I need to do to get n by itself is I need to undo this minus 10 by adding 10. So I get for my final answer n equals 10,010. You could get some kind of large numbers with here because exponents make things get very large very quickly. Also not a problem. Last one, like I said, base was 10. Here's for me is a 10 base to cancel these things out. 10 squared is 10 times 10, which is 100. And now we just get k by itself. So add 1 and divide by 6, negative 6, sorry, and you're going to get a fraction, and that's okay. Final answer here is negative 101 over 6. If you'd rather write it as a decimal, that's fine too. That is it for today. So just to recap, if you have log on one side of the equation, to undo or cancel out that log, use a base that matches the base of the log. When you don't see a base, then your base is an implied hidden 10. That's it. Have a wonderful day.